Today we talk about the most fundamental concept in mathematics, which is pi. So pi is, people say it should be 3.41, whatever, not ending, somehow random and transcendental. We don't know what this is. It is known some equation that the E, something like that, imaginary number should be -1. So this is the most fundamental identity, mathematicians say, but it is based on the idea of pi should be this. And there's a big question mark. What is this all about? If we discuss the space-time or space in general, I see space is measured with length. So I have point A, point B. And this is a one-dimensional length. And then I can add a second dimension. So we have something like that. This is one, this is one. We have a box 1 of 1. And then we have two-dimensional space, which is, you can say, 2 to the square is 4, and 3 to the square is 9. And this is the surface calculated with this. But to do so, we need this to be a 90-degree angle, because if you say we have 2 dimensions which are in like this, and if this is 1 and this is 1, the surface looking from this perspective, this is not 90-degree. This is like 15, something like that. So now if we have two-dimensional space, and this is exactly 1, this is 1, and this is 1, this is 1, but 2, but 2 to the square is not 4, so something whatever. Therefore, to understand two-dimensional, the flip from one-dimensional to two-dimensional space is the connection of space and time. Space and time is proportional, so I have 1 meter is the unit of length, and then I use a perfect circle to go from point A back to point A, which is the time, 1 second. So this is 1 second, and this is 1 meter. And we use this perfect circle to use to calculate the 90-degree with Pythagoras. A to the square plus b to the square is c to the square. So then we receive the number, so we defined pi is the relation between diameter and circumference and diameter is 1, so 1 second per meter. And this then becomes, we can say this is then the surface for 1 unit of space-time. So we have 1 diameter to the square is 1. And we can flip this also in two-dimensional space-time. So we have this is one-dimensional space-time. This is one-dimensional space-time. So this is a point, and then it goes in one line, and the two-dimensional space-time would be like so. Then we have a box, and this is a diameter of 1. So this is, here we have 4 connections. This is 4 units of length, and this is 4 units of length. So this is 16 space-time units of space-time, so meter per second, second per meter. And included in this is the Euclidean geometry. So we square the box, and we can count discrete pieces of space-time. So 1, 2, 3, 4 pieces of space-time, and then we resolved the irrationality and transcendental understanding of P to explain the meaning of P in 3 dimensions. So in 2 dimensions, P was a relation between the circumference and the diameter in 2 dimension. So it is 1, and then we create with this the number of 2. So because we created the radius and we split up in 2 dimensions. So and created the natural number 2 with this. Now we can explain how to use pi for 3 dimensions. So we have a 3-dimensional sphere, and the volume of this is volume is for radius, and the surface of the sphere and the relation between both. So the relation other in 2 dimension, the relation between circumference and diameter. Now we look at the relation between volume and surface. And this is volume per surface, and this is radius in 3 parts. So this goes, this goes, this goes, this goes, this and this. And then we have the radius. It was half a diameter. So this is written, half a diameter is per 3 is the relation between volume and surface. So maybe this is it. So maybe it's just to create in 3 dimensions. Pi is used in 3 dimensions to create space-time. So same as we have space-time in 2 dimensions is like a box of, this is in 2 dimensions space-time, and in 3 dimensions space-time, of course, you have like this. So this is 2, 2, 2. This is 2 times 2 is 4 space-time in 2 dimensions. And here you have for 8 elements of space-time. Having shown the elementary concept in mathematics, we can show with this the elementary concept in physics. So we have a one-dimensional, this is a second per meter, which is in physical analysis, and this is meter, this is second, one piece of space-time, which is the gravitational constant is second per meter unit. Then we can create two-dimensional space-time. So we have let's make it 2 second per meter times 2 second per meter is 4 second per meter to the square, and second per meter is the elementary charge, is Coulomb. And in three-dimensional space-time we go to, so this is elementary charge standing for electricity, gravitational constant, electricity, and in three-dimensional space-time we have 2 to the 3 is power 8, and we have second meter, right? And this is 2 times 2 times 2. We need so this is to expand from one dimension into 3 dimensions. We have 8 second to the third meter to the third, and is the dimension of the Boltzmann's constant, where the inverse of that is the dimension of entropy. So there we go. There we have the 4 for the gravitational constant is 1 per whereas this C belongs to this pi, belongs to this relation, and end up in this. That's it. So what to say in the end? Is irrational nonsense.